So now we are recording. Welcome everyone. Thank you for joining me. And let's get started. Before we delve into the last topic for the midterm, I just would like to give you an idea about the format for the exam, which is happening next week. So I'm planning on opening the midterm on Sunday morning, and then I'm thinking about leaving it for 1 week to give you guys flexibility all the way up to Sunday or Monday. So my question here is, do you prefer that I close the exam Monday or Sunday? Because usually weekends in my house tend to be pretty hectic, so that's why I'm considering just closing the exam, allowing you to have one extra day. So Monday. Let's then make Monday the final. Yes, I know many of us are dads and moms, and it's pretty hectic sometimes the weekends. I just think that Monday gets back to normality. So I'll make a note to myself to close the exam on Monday at midnight, and that will be the deadline. Now, in terms of the content and format, so we're going to be covering everything we saw all the way up and including this lecture. So 2-stage least squares will be on the exam. In terms of how the exam should look like, I'm considering multiple choice questions for the majority of it, and then having about, I would say, 40% or so with open questions, maybe I would say 2 or 3 open questions depending on the amount of multiple choice questions that you guys would have. So I'm thinking about a 3-hour exam. So you can start at any point, but once you start, you gotta finish. You will not need to be logged onto Stata, okay? Because I don't want Stata to get on your way. Maybe you're overseas and you're not able to connect very much with you anywhere. So what I'm thinking is, the way Stata can show up in the exam will be through, you being able to interpret outputs. But other than that, being able to recognize a Stata output and tell me what's going on there, a hypothesis testing, or maybe a regression output, or maybe a 2-stage least squares output, and be able to be comfortable with those. Okay, so understand the t-stats, where do they come from? Those things I think you should be comfortable with, and that's what I'm thinking. So no need to memorize commands. I will not require any memorization in terms of Stata commands, and also usage of Stata. So everything is going to be self-contained in the exam. You will not be needing an extra resource. You're free to consult other sources, your book, but if you know where the material is, that is going to give you time and agility to just, be able to look at the right chapters. So if it's a question on regression, well, you should know, I would make a list to myself saying, hey, I should be looking at chapters 5, 6, and 7. Or if it's a question on hypothesis testing, a simple hypothesis testing, I should look in chapter 3. Or if it's a question on average treatment effect, well, I know it's chapter 4. I think that way is going to save, at a minimum, it's going to save you some time. Because if you're going to research every possible question, you don't have those, so easy on your mind. I think that can be something that will not be so efficient for you. So that's basically what I'm thinking for in terms of the midterm. Are there any other specific questions that I can answer before we get started? So and I will ask the same question at the end so you can think about. And then, so the exam is timed, it's 3-hour limit, and you can start anytime, but once you started, you have 3 hours to complete. Okay, so before you sit down to do your exam, make sure the kids are well taken care of, make sure that you don't have to worry anything about that. So Yon is asking me about the time zone. Don't worry about that. I'll times in such a way that you will have, everybody will have a chance to complete within a reasonable time frame. If more questions come, please ask them at the end. And again, you can interrupt me at any point during this lecture. So this is a very important topic. the topic that we're going to discuss today, if you have not taken econometrics before, it may be a little bit more challenged, but I hope to clarify some of these concepts for you. So the reading is not that intense. You basically have few pages in chapter 8, but the idea is sophisticated. So this is the two-stage least squares method, one of the more advanced methods that we are trying to come up with in order to mitigate our biggest problem here, which is endogeneity. So I have something else to talk to you, but I think I'll leave that to the end of the class. So I'm trying to make some contacts with the CEO of Cook Medical. I don't know if you guys have heard about Cook Medical, but it's a global company that sells medical devices, medical products, and it turns out that the CEO, it happens to be my neighbor. So Carl has agreed to put me in contact with the business inside, and I'm always worried about bridging this gap between the business school and you guys, bringing you guys closer, sending you guys, to opportunities that we have, making sure you open some doors and be able to at least have more contact with the industry. So we'll talk more about that, but that's something I'm looking for. And I'm contacting them, and I hope to be able to bring them to class if it's in your interest, even if we have to maybe condense some of the topics. So we'll talk more about that later. All right, so let's focus on the material for today. What is it that we were discussing last class? Well, we were trying to estimate a demand function. What is a demand function? Well, a relationship between quantities and prices. So here we have a company that is asking a pretty simple question. What is the optimal price that I should place my product at, right? And in order to answer this question, in order for the company to be able to know if that company is maximizing profit, marginal revenue equals marginal cost. I'm sure you guys have gone through that. An essential part of that is to understand the demand function. So the demand function is just a basic equation in which you have quantities and prices related, right? So I think you guys are very familiar with that. So this is the very simple question that we're trying to answer. We collect data on prices and quantities, and we start with a very simple regression model, right? So the simplest kind of model we can think of is let's just regress quantities and prices, right? So when we do that, and we can run the regress command, we're gonna get a coefficient here that is around 1, significant. The problem with that regression is that this regression is too simple to be true, right? So what is the problem that we've been talking about? What is the problem that this regression have? Is it multicollinearity, heteroscedasticity? Is it endogeneity or truncation?
Endogeneity.
Endogeneity, very much true. So this is the biggest thing for us. This is our biggest, obstacle in trying to really claim that we have no bias and that we have causal relationships. So the problem with this regression, and it really does look strange to have a positive coefficient in prices, right? So that does raise some red flags right away. When I look at the relationship between prices and quantities, I'm thinking about the economic law of the demand. When I increase prices, my quantity should go down. So that, to me, already raises some red flags saying that I must do something, right? We gotta take some action here. The first, so what is the nature of that endogeneity? Why do we have an endogeneity? And you wanna go back to average treatment effect, where ideally the holy grail thing is that we would have random assignment and random participation. The problem that we have now is that, of course, prices do not get chosen randomly. So managers, when deciding how much to charge to for their products, well, they're going to pay attention to willingness to pay. They're going to pay attention to market forces. They're going to pay attention to market size, to consumers' preferences. And of course, they are not going to throw a coin and decide on price. So price is not randomly chosen. And we know that when that happens, we have selection bias, right? So we are going to have a biased estimate of our coefficient. That's the problem. So what we want to do is deal with that problem. How can we remediate? Given that we cannot 100% fix the problem, what are some things that we could do? And I have some suggestions here. What could we do here? What would you advise me to do?
Instrumental variable.
Instrumental variables, definitely. What about the first one? Truncation. Well, it's not going to get us anywhere. So Priya is talking about controls, Chandra instrumental variables, Manish instrumental variables, absolutely. So all the last three options are viable. Controls, IVs, panel data. But the last one is only if we would have time, only if we would have observations that are changing with time as well. So if we could collect sales data across many periods for our many branches, then we would have also the possibility of using panel data methods. And this is something we're going to talk about after the midterm. Okay, so let's start with the first remedy. The first remedy, something that we discussed last class, is to just bring things out of the error term. And ideally, we would like to include everything that we can that we know is related to price and also sales. So when we think about income, for instance, income being contained in my error term, we know that higher income leads to higher disposable income, which leads to higher willingness to pay and higher willingness to buy. So we have identified a plausible correlation of an omitted variable, income, and our treatment prices. So ideally, what we want to do is to bring income out of the error term with having established these reasonable correlations and now control for income. So what that means is that when I change prices, income is not changing concomitantly. So that's something desirable. So when I do that, and you guys are welcome to just run this regression, is a simple regression. We have done this exactly last class with market size. We know that we get a smaller coefficient over here. My coefficient is smaller, but it's still bothering me the fact that this coefficient is positive, because I know that when prices go up, quantities should go down, unless I have some weird giffen good type of thing, an abnormality that we studied in microeconomics, and that's not going to happen for the majority of goods. So we're better, but we're not still doing the best as we can. So the next thing we want to think about is that, you know, even including all the controls that we can think of, it may be very difficult to get rid of endogeneity. It's not so easy. It's not so easy to measure things that we need to measure, and may not be easy to proxy for some things that we think is necessary to be part of the model. So one of the things that we can think of in terms of this example is the idea of competitiveness, right? So imagine that we have this omitted factor, competitiveness, sitting there in our error term. Well, let's go through the economic correlations over here. When competition is higher, what's going to happen? This is going to create an intense competition, an intense game within the firms, and that's going to push prices down, drive prices down. Also, when competition is high, we know that customers will have a lot more options to choose from, so therefore your own quantity will go down. So it's important that you go through this intuitive reasoning when you're thinking about endogeneity. This is something I always look for in your homeworks, right? So when you're claiming something is endogenous, go through the correlations. Tell me why you think that something is related to your treatment and your outcome. The problem with this factor, competitiveness, is that this is kind of a nebulous idea, right? It's difficult for me to just assign a single number to competitiveness. Even if you raise your hand now and say, what about Hirschman-Herfinda index and all those things and the C4 ratio that we studied? Well, that may be true, but this is kind of an abstract idea, a lot like intelligence when you're thinking about wages and education. So we have identified this omitted variable, competitiveness, which is plausibly related to prices and also sales, as we have just argued. So here comes the idea of, but the problem is that we cannot proxy for, we cannot control for. So here's where two-stage least squares may work, right? If we somehow can find a candidate, an instrumental variable that allows us to be able to isolate movements in prices, they are exogenous, they are not related to competitiveness, well, we can break down this endogeneity problem. And that's the whole idea behind two-stage least squares. That's the whole philosophy, right? So what we are looking here is to be able to find a good candidate, a good instrument for our endogenous variable, in our case, price. So let me just bring this equation once again. So here's my regression. We have sales as being the y variable. And in the error term, we have these things that are very abstract, like competitiveness, right? And other things. And I'm worried about this omitted variable. This is something that, people are gonna be concerned about. Because competitiveness is in the error term and I cannot control for and I cannot measure for, let's say, that causes my price, my variable x1, to be endogenous. So what I'm going to do is to try to find a variable that is related to my treatment, that somehow shocks my treatment, that provides variation in my treatment. My treatment here is price, the problematic variable that is endogenous. But what I also want from this IV is that it is not related to competitiveness. So it gotta move my price in ways that is unrelated to competitiveness. So let me see if I can draw this thing for you, because I think this diagram facilitates the visualization. So price moves because of many things, right? Price is gonna move because competitiveness is moving, and that's something we don't like. That's something that I'm gonna call a bad variation. So this is a bad variation, but price may also be moving because cost factors, production costs, production and distribution costs are also moving. And let's imagine that this is fuel costs, right? So I'm gonna say that fuel cost is my instrumental variable. And when fuel cost is moving, price is gonna move, but in ways that is not related to competitiveness. If I can argue that, then I'm breaking down this correlation and I'm moving forward, being able to establish causality, right? Because what really is gonna give me biased estimates is the fact that price is endogenous, is the fact that price is correlated with competitiveness. But if somehow I can dissociate those movements and I can only, retrieve the part of price that is not related to the bad variation, to variation in competitiveness, well, that's ideal. That's gonna help me really mimic this holy grail kind of random assignment, right? Because ideally your IV variable should be a variable that is related to your endogenous variable, but is not related with anything else in the model, okay? So that's the whole philosophy. If you understand that, you understand the technique, because that's the whole intuition. Yes.
I have a question. So if fuel cost is correlated with price, right?
Right.
Because they need to be related in order to extract the portion of the variance, then fuel cost is also influencing Y, because if it's correlated with X and X influences Y, then fuel cost is also influencing Y.
That's a very good question. We're going to make an argument for why this is not true. Okay, so hold on one more slide and we're gonna talk about that. Okay, so let's think about, and here's a typo here, what are the really requirements that fuel costs should fulfill if we want fuel costs to be a valid instrument? Okay, so we're going to require two things, and if you read chapter 8, you probably know that answer. What are the two things that we need? We need fuel costs to be exogenous. We need fuel costs to be relevant. Okay, so let's talk about the easiest one. Let's focus on the first one, relevance. Okay, so intuitively, it makes sense that when fuel costs increase, production costs go up, distribution costs go up. So those are input costs, right? Costs of inputs. And you all studied microeconomics. You have seen before that when the price of an input go up, this is a supply shifter, right? And therefore my prices will respond going up. My cost has gone up. I'm going to charge consumers a higher price. So intuitively, it makes sense that we have a relevant relationship over there, that when fuel cost is increasing, my price is increasing as well, a positive correlation. And that may be something that you should go over when you are presenting your results, right? So maybe you have people from different fields, you always want to defend in intuitive terms with economic explanation first before you even do any econometric tests. However, this assumption is also easily testable, right? So how can we test for this assumption? We're going to do exactly what you just asked me. So we're going to establish a relationship between the endogenous variable x1. Remember that this is the problematic endogenous variable. So here's price. We're going to regress price on my instrument, fuel cost. And usually instruments, we denote them with variable z and the controls. We always keep the control. So this equation here is also known as the first stage. And it establishes a relationship between your endogenous variable and your controls and your instrument. So what we want from the first requirement is that, yes, this fuel cost must change prices. And well, this relationship doesn't even need to be causal. We just need to see a changer, right? We just need to see a shocker there. So we just basically need correlation in that sense. So for you to establish relevance, what you want to do is to really conduct a very simple hypothesis test, and we're going to go over that with an example soon. So you want to look at the coefficient here, delta 1, and all you're going to ask is that delta 1 is different from 0. You guys are tired of doing that in your homework, right? So you know how to see if something is significant or not, just based on the t-stats of your regression output. So relevance is pretty straightforward. What is not straightforward is exogenous, right? So as the question that was just asked was worried about is, well, if that variable is changing prices and prices is over there, of course, this variable is going to affect, of course, my IV is going to affect sales. First of all, proving that something is endogenous is really easy, right? So in your homework, you have done something like that. So basically all you need to do is come up with a counterexample. You need to come up with an explanation why you think that variable is in the error term and is correlated with the treatment. So proving that something is endogenous is no problem. Proving that something is exogenous is a lot harder. Mathematically, what we need is that the correlation between that variable and your error term be 0. So all we need is that. The problem here is that we don't observe epsilon. We don't observe the error term, this unobservable component. So one of you may just say, hey, Juliana, what if we do the regression, retain the residuals, and then we just do a correlation, simple stata command, we just correlate those residuals with our instrumental variable, and then we see if this correlation is statistically zero, different from zero or not, right? So you may suggest something like that. The answer is that's not going to work because, first of all, the regression that you run in the first place was a regression that had an endogenous variable, right? So your residuals are already picking up this endogenous effect. So just, mathematically running a correlation is not going to take you anywhere. It is really impossible for you to have a very clean test of this requirement. So how do we get away with this assumption? This is something that you're going to have to convince your audience. This is something that you're going to have to be creative about it, that you have to think really about, right? If that candidate is plausibly exogenous. So here's the logical argument. For something to be exogenous, it means that that something is going to affect your Y variable only indirectly, only through prices, right, in our case. So if fuel cost is a good candidate for fuel cost to be exogenous, when fuel costs go up, prices are going to go up, but this is not going to affect sales beyond the effect of prices or beyond any other controls that you controlled for, right? So let's think about cereal, right? Let's think about a box of cereal. You're going to the supermarket and you're purchasing cereal, and I'm interested in estimating the demand for ready-to-eat cereal. When fuel costs in general go up, right? So the price that consumers are paying to fill up their tanks, well, this may affect the price that they pay for cereal. This may affect the budget that they have available to buy cereal. But if I control for those two things in my regression equation, that is not going to have a discernible effect on sales anymore, plausibly. Okay, so you can think about also cereal as being a very inelastic product. So when fuel costs are changing, cereal occupies a very small portion of a family's budget. So when they are going to the supermarket to make their cereal purchases, your typical consumer, they're not going to be thinking about the effect of those higher fuel costs when they're picking up this cereal box. Again, of course, the price is being changed, is affected. Of course, their income, their budgets is affected, but not beyond those two things, not other discernible effect, right? So that's the argument that I need to go through in order to convince myself that, this cost factor, this input cost is something exogenous, okay? So in that case, there will be an explanation. We're trying to estimate a quantity demanded. We're trying to estimate a demand function. So I'm going to use my economic concepts. I'm going to use my financial concepts, my accounting background. That's why we need this critical reasoning to be able to argue that a supply shifter is not going to be something that affects quantity demanded. It's going to affect supply. Cost always affects supply, change supply, but not quantity demanded. Okay? So in theoretical terms, it's plausible to think about cost factors when you're estimating demand functions, quantity demanded. Okay? So usually every analyst that is trying to estimate a demand is going to look for things that change supply. And if this analyst is trying to come up with an estimate of a supply function, he's going to think about demand shifters, okay? So, and this can change from field to field, accounting, finance, and other things. So if, and again, a person may disagree on your argument. If that person disagrees on your argument, and this is usually what causes very much heated discussions, whether exogeneity is plausible or not. Of course, there are situations in which it's more plausible than others, and I'll go over some examples at the end of the class with you. So having established those two requirements, relevance, exogeneity, we can go ahead, right? So again, going back to the question that was just asked, fuel cost is an instrumental variable. When fuel cost is changing, price is going to change. But what we want from exogeneity is that fuel costs don't directly affect sales, only indirect via treatment, okay? So we're able to dissociate those two effects. Any questions? Let me pause here and ask if there are any questions before we talk about implementing this thing.
Professor, this is Manish. Excuse me. So in terms of conceptual understanding, I think what I understood so far is that even though cost affects the quantity demanded indirectly, but for a given price, it does not. For a constant price, it does not.
Cost is going to affect your price, right? Because if you're facing higher production costs, this is an input. So let's say your input costs are higher. I use fuel for my distribution channels. So when fuel cost goes up, my input goes up, my input cost goes up. Therefore, my price goes up. But when fuel cost goes up, that doesn't directly affect the quantity demanded, the sales of that product. This is the argument. Manish.
Right. So in other words, for a given price, for a constant price, cost does not affect the quantity demanded. Is that a fair statement?
That's a fair statement.
Okay, perfect.
That's a very fair statement. So having established those two basic requirements, we can go ahead and implement 2SLS. Okay, and then I'm going to teach you also how to run some tests to see if you actually need this technique. So what if you understood this philosophy of what we're trying to do? Again, what we want, and this picture is excellent for that. I really want to go back to this picture. What the whole idea is really, let's isolate variations in prices. They are only related to fuel cost, my instrument, and let's throw away variation in price that is due to competitiveness, that is due to this omitted variable. That's the whole philosophy. And if that's the whole philosophy, that means that our technique needs to do exactly that. So we're gonna talk about now the two-stage least squares method. What is the two-stage? So the idea is very intuitive.
Oh, so Professor, before you move on, I just want to go back to that first stage where you showed the diagram.
Mm-hmm.
So in this diagram, if what you're saying is the shaded portion is the correlation between price and fuel costs.
Correct.
So by then using fuel costs as a proxy, we are only bringing in the portion that the fuel cost affects the price. Therefore, we are throwing away the other portion.
Everything that you've said is correct except for the word proxy. Because if you're talking about a proxy, that means that variable should be in the regression. And that variable Z is not in the model, is outside.
Okay, but if the instrumental variable is representing the variation in price, when price is regressed on fuel cost, the residual is all the stuff that is outside the fuel costs.
Fantastic.
The residual is that correct?
That's perfect.
The residual is representing all the other stuff.
So what do I want to do with this residual then? Throw it away. Throw it away. Just let me keep the part that is due to fuel costs. You got the whole idea. That's essentially what the two-stage least squares method is going to do. So let's just translate what you have said. In the first stage, I'm going to regress the problematic endogenous price on my instrument and my controls. Always, you want to keep your controls. And then I'm going to just get that part that is related to fuel costs, right? So how do I do that? I'm going to save the predicted values of this regression. I'm going to get rid of the residuals. I'm going to throw away the residuals and just use the portion of price that is explained by fuel costs, that is correlated with fuel costs. I'm going to retain those, okay? And we're going to call those X hats, right? Those are the predicted values, the ones you guys normally know how to get. So how do I translate that in terms of my example? You basically just need to run a regression of prices on fuel costs plus controls, and you're gonna get the predicted prices. When you do that, you're just getting the portion of price that is related to the good variation, the variation that is not endogenous, the variation that is unrelated to competitiveness. That's it. Once you retain that portion, take that good portion and stick in your original regression, and you're good to go. So finally, in the second stage, what are we going to do? Take those X hats, those predicted prices, and we're going to use them in the normal regression. That's the second stage of the two-stage least squares. Let's just now get our hands dirty and let's just implement this model together, okay? So let me hop on Stata right now, then we can do this estimation. So let me run the first stage, right? I'm gonna regress price, price, my endogenous variable, on what? On my instrument and my controls. Whatever controls you have, stick them out there because they also help with endogeneity, right? You want to keep your controls everywhere you go. So that's the first stage. Are we good? So here's the question I want to, you guys, if you paid attention at the first requirement, is this a valid instrument in terms of relevance? Is this a relevant instrument? I run the first stage. Do I have a relevant instrument? Yes or no?
There's no zero included, so yes.
Yes, we have a pretty large t-stat, so we're good to go. Let's go to the second stage. How do I go to the second stage? Let's just retrieve the good part, the good variation. So let's predict, let's call it a name, whatever name you want. So P hat, let be price hat, estimated price, whatever you want, price fitted, option XP. Again, this is how we retrieve predicted values. Stata is going to calculate those. And let's now run the second stage. We're going to regress the original regression sales, not on prices anymore, not on prices, but on P hats, right? So on P hat and your income, and you're done. This is the second stage. Now, what this does for us is that this coefficient on P hat looks a lot more reasonable, right? So we have a negative coefficient on prices, and that's something desirable. So it makes sense. So this is the manual version. But it turns out that Stata has a built-in command that is going to do all the two stages together. And all you need to do is to type IV regress. If you just type IV reg, some of you have asked me about this IV reg. This IV reg, if you just abbreviate to IV reg, this is an outdated version. We now have a more updated version, IV regress. And we have many IV regresses. We want the two-stage least squares, okay? Now, what is the syntax? You want to list your outcome variable first, sales, as we always do. You want to open a parenthesis, list your endogenous variable, equal sign, instrumental variable, fuel cost, close parenthesis, include, and again, I'm going to post these commands after class, so you don't need to worry if you have not have a chance to see them all. I'll post all of those for you, okay? So sales, endogenous variable equal to your instrumental variable, and then your control, income. As many controls as you possibly have. As you can see, so let me just bring my screen, my command window down. You can see when we do the manual version, running the first and then the second stage versus doing the automatic version, look at the first column. We get exactly the same coefficients. So the coefficients are going to be exactly the same. The only little problem that we have here, this is a warning, is that the standard errors are going to be off if you do the manual version, okay? So if you want to look at inference tests and hypothesis tests and confidence intervals, the better version, the version that has the standard errors corrected for you, and this is a built-in routine. So behind the scenes, this data is really adjusting these standard errors for the predicted values. So these standard errors with the automatic command, those are the real ones. Those are the good to go ones, okay? And you can see that they are a little bit higher, larger than the manual ones, all right? And it's gonna be often the case that standard errors, when you do a two-stage least squares, they're gonna be higher than OLS, okay? So usually when you compare OLS with two-stage least squares, you usually will have higher standard errors as well. So again, the punchline of all that I just said is to make sure you have the correct standard errors, go with the automatic version, okay? And I have listed both for you.
Professor, it might be a little off topic, but I noticed that in two-stage manual mode, we got t-stat, however, in the or t-value, but in the two-stage least square, which Stata took care of it, we got the z-value and a chi-square.
Yeah, this is a derivation of the test statistic, but basically you can compare these z's and these t's. You can compare the z's and the t's with the critical values that you're used to as normally, because t's and z's approximate when you have, you know, a large enough sample. So this is not something for you. This is not going to be a concern in moving ahead with the test that we have done. So this comes from the derivation of that statistic, right? So here it has to deal with the population standard error, but you don't have to worry about if you have a large enough sample, because you can just eyeball that and see, use the 1.65, 1.96, 2.58 values that you're used to.
Okay, thank you.
So now eyeballing here the comparison of the three models that we have done. So, and it's usually a good idea when you're, you know, doing a project or anything like that to have alternative models, right? So it's a lot more robust to show your audience that you have somehow progressed from a simple specification to a more complex model that includes your controls. That's column number 2. As you can see, we have the control here included, to a third specification where you have this more advanced technique, which is the two-stage least squares. So it's a good thing to show this progression, to show a table with different versions of your estimates. And here, you know, the sign flip is very appealing, right? We would hope that the relationship between prices and quantity is really negative. So really having a more conscientious type of model is what we're trying to come up with. We're not trying to come up with the whole perfection of the universe, but with something that is a little bit more careful. That's the goal. Again, we talked about why this method works, but let me just repeat that message. What is the idea? We had this omitted variable competitiveness lying in our error term. What we have done was to take the endogenous part of price and get rid of it, right? So when we type that Stata command predict, all we're doing is say, let me keep the portion of price that is explained by that is correlated with my IV, and let me use that good variation. When I say good, I mean good in terms of not being correlated with the error term. If you think about competitiveness, of course, competitiveness is not going anywhere. Competitiveness is still in your error term. But what we have now is we broke the correlation between price and the error term. We don't have a correlation between price hats and the error term. Or again, because of this exogeneity idea, right? So we stripped out that that part that was causing problem. That's what an instrumental variable is always going to do. It is always going to be something that shocks your treatment, and through that treatment, it affects your output, not directly, but via this indirect mechanism. Let me just give you a quick word on what we mean by weak instrument. What if you find that, you know, you have a very low relevance, that fuel cost is not so strongly related to prices, okay? So that will be a weak instrument. A weak instrument was going to be a very weak correlation between your IV and your endogenous variable. If you have that problem, that is not going to cause you any bias whatsoever, so you're still going to have unbiased estimates. But the problem with that, of having weak instruments, is that you're going to be facing a lot more imprecision. The reason you're going to have a lot more imprecision is that when fuel cost is changing, price is changing only very little in response to that. And so you're going to have a lot less variation in your treatment. And remember, this is the big lesson in econometrics: the more variation you have, the better. Because the more variation, the more you learn, the lower are your standard errors. So if you have weak instruments, you're going to have a lot higher standard errors, okay? So that's the problem. But still, beta 1 is going to be unbiased. So here we have done that before. We know that after running our first stage, fuel cost is statistically significant, is a strong instrument, not a weak instrument. How do I know if I have an endogeneity problem, right? How do I know if I need to use two-stage least squares? The best way is through your economic intuition. When I mean economic, I mean accounting, finance, marketing intuition. So use your knowledge to check for red flags. In my case, being an economist, I know that the law of the demand needs to prevail for the majority of products. So here, finding a positive coefficient is something that is calling my attention, is something that is weird. And whenever you have this thing in front of you, it calls you to think about the possibility of endogeneity that you need to remediate. Another thing that you can do is run some endogeneity tests. And I have two here that we can do. They are known as the Hausman tests, right? So why would you present these endogeneity tests? Well, ideally, you want to keep your OLS model, right? So ideally, you want to stick to your benchmark basic OLS model. You wouldn't go the avenue of running a two-stage least squares if not necessary. Why is that the case? The reason is that when you go into this higher order instance of running a two-stage least squares, you're going to be facing a little bit higher standard errors. So you're sacrificing a little bit precision in terms of the OLS benchmark case. So you will do it for the right reasons, right? If you think that you have really endogeneity you're facing this problem both on a theoretical term and also diagnosing now through this Hausman test. So let's go through two versions of this Hausman test. So the first version is, we're going to run the first stage. What I mean the first stage is, again, the relationship between my endogenous variable, my instruments and controls. We're going to retrieve now, not the predicted values, but we're going to retrieve the residuals, okay? We're going to retrieve this part that is related to competitiveness. Finally, we're going to take those residuals and we're going to stick into the original model. And we're going to do a hypothesis test on those residuals. If they're going to be significant, we're going to say this model is suffering from endogeneity. So let's demonstrate how we do the Hausman test with our model, with our data. Okay, so let's run the first stage, regress price on instruments and controls. This is my first stage. I'm going to now retrieve my residuals. So how do I retrieve residuals? Always with when you retrieve something, remember the predict. We predict, let's call resid option residuals. There we go. Now we're going to go back to the original equation, the original structural model, so sales on price, income, and now bring that in residuals. If that thing is significant, we're going to be concerned about endogeneity. So running this regression, let's take a look at the results. We see here that the coefficient on residual is massively significant. So that is a concern that is going to, you know, be indicative of endogeneity. So that's Hausman version 1. Another version you can do is just to think about these two models that we have. We can run a basic model with no instrumental variable, and we can run the instrumental variable model, the two-stage least squares. If we don't have endogeneity, we are going to argue that the estimates we get from the simple OLS model are going to be very close to the IV model, to the two-stage least squares model. So basically, we're not going to have enough difference between those two estimates. So this test is going to do exactly this idea. It's going to compare your estimates from running a model, basic OLS, versus running a model two-stage least squares. It's going to check to see if your estimates are very different, right? If they are different, well, this is indicative of your endogeneity. So how do we do this test? We're going to run the regular regression. We're going to store our estimates. We're going to name them. Then we're going to run the IV regression. We're also going to store, name it. No IV, IV. Finally, we're going to type a command, Hausman. This is already built in on Stata. And then the IV version, no IV version. And what this is going to tell us is to see, is compare these two versions. So let's go ahead and do this now. So this is Hausman version 2. So let's regress sales on price and income. This is just basic OLS. Okay, those are your typical OLS. And let's type estimates store. Let's give it a name. So let's call no IV. Let's now run the two-stage least squares. So IV regress, this is something you're going to do in your homework, 2SLS, and then we already did that, right? So sales, endogenous variable, equal instruments. Let me just say income. So one thing that I want to mention here is that you can have more variables on the right-hand side and on the left-hand side of these parentheses, okay? Just one thing you need to remember is you need to have enough instruments for as enough instruments as you have an endogenous variable, right? So if you have 2 endogenous variables, you need at least 2 instruments. So you can add variables both sides of this equality. Type that, and then now estimates. Let's store. Estimates is store. And let's name it IV. Okay, finally, Hausman, IV, no IV. Okay, and what this test is testing is the null hypothesis. What is the null hypothesis? That you don't have a systematic difference between between those estimates. Of course, this is going to have a statistical distribution. Here is chi-square. But the interesting thing that you can, the very easy thing that you can do is to look at the p-value. The p-value is less than 5%. So that's the beauty of p-value, right? You can just establish your confidence level and immediately you have a response. So here, because the p-value is 0, less than 5%, we're going to reject the null. We're going to reject that the difference is not systematic. So again, indicative of endogeneity. Let me go back to, okay, so Austin is asking me, why does Stata list income as an instrument? That's a very good question. So Stata is going to list not only your instrumental variables, but also your controls. Why is that the case, Austin? Because income in our case is plausibly exogenous, right? So when you are controlling for income, for Stata, this is also working as kind of an instrument because it is not problematic. So that's why it's gonna have this notation of listing not only your IV, but also your other axes or your controls. Remember, when you are running your first stage and your second stage manually, okay, and you can do this in Excel, let's say you don't have Stata, you wanna do in Excel, you're still gonna get your betas. Remember to keep your controls in both versions. They never go away, okay? So the controls alleviate the problem. We should keep them all the time. You don't need to memorize so much those tests, but understand the idea. Of course, I'm not gonna be, testing you on epsilons and deltas, very specific notation and things like that, but have this idea, okay? For the rest of this class, I just want to give you a couple of simple examples of instruments, okay? And when you're writing about your instruments, make sure you explain your choice of instrument. Make sure you talk about the two criteria that we discussed, exogeneity, relevance. If you are going to be doing that in your project, make sure you back up your use of an instrument. This is something important, right? As a convincing part of your motivation to run in a two-stage least square version. So be prepared to defend the assumption of exogeneity. We talk about this assumption being the more not so straightforward one. What are some types of instruments that we can think of, right? Ideally, your instrument is going to be something that is mimic an exogenous random process. Right? In our case, was a cost variable. Cost variables are effective if you want to estimate demand equations. The whole usage of two-stage least squares for demand is going to bring usually a cost variable. So it's not strange, definitely, to use those cost variables. But also we have sometimes opportunities to see this exogeneity or this randomness of IVs in practice, right? So let me give you an example of the Oregon Medicaid lottery. So the question that we were trying to answer here as health economists were how insurance affects your health, right? So when people buy more insurance, do they have better health? That was the question being asked. Well, what is the problem with this regression?
Who buys insurance is not randomly selected.
Very good. And be prepared to answer that in your exam, right? Identify sources of problems. So why is that not randomly selected? So give me some explanation. So usually the wealthier, the more educated, the richer, the older people would buy more health insurance. So therefore insurance is not randomly selected. So we have a problem, endogeneity. How did we get rid of this problem? It turns out not everyone has access to insurance. So give me examples of things in your error term, right? That are correlated with insurance and health status. So if I ask you a question like that in your exam, be prepared to talk about something in the error term that is related to your treatment and also your outcome. Because what the typical answer that doesn't get this answer right does is just say, oh, there are other things in the error term. That's too general. If there are other things in your error term, this is just going to cause you problems of precision. The problem comes when those other things in your error term are going to be correlated with insurance, of course. Bringing back to what you just answered, insurance is not randomly selected. So what happened was that Oregon decided, of course, being limited on budget, decided to conduct a Medicaid lottery, right? So it would invite eligible people to apply to the lottery, and then 90,000 people applied to the Medicaid lottery and only 30,000 got selected. Well, it turns out that the lottery is going to affect, and then these people had the choice of whether or not to enroll in Medicaid. So here we have an opportunity to use an IV. Medicaid lottery is going to change insurance enrollment, but the lottery is unrelated to health status. So we have this really random lottery that is changing the treatment insurance, but in ways that is uncorrelated with stuff in the error term, right? So uncorrelated with health status. So this is an opportunity, a very good usage of a policy change to identify NIV. We have lots of those. So military drafts was one that was looked after and things like that. And you want to be creative, right? So let's give another example here. You want to estimate the effects of advertising views on sales. What is the problem with this regression? Well, people that tend to buy the product more anyway would be more inclined to view this advertisement anyway. So what will be a good instrument for that variable? Well, you want to be creative. You want to think about, things that randomly change views. If you have stuff that is random, this is not correlated with anything else, right? So what about, here's a suggestion, power outage. So things like that. This is exogenously changing my treatment. Very much random, unrelated to other stuff. Another one, broadband demand and speed of your internet. Problem here, firms may offer better speed in better markets, in markets with higher willingness to pay. What could be an instrument? Well, something that would change speed, but maybe unrelated to the quantity demanded for broadband, right? So here, physical terrain would be a candidate. So this is the whole philosophy of a two-stage least squares, trying to come up with random things or plausible changers of your treatments to really dissociate the problem, to really dissociate this endogeneity. That's the whole idea of a two-stage least square. And the implementation follows exactly this idea, right? Let me pause here. I think we're basically reaching our time limit. Are there any questions? There's one thing I need to say. I'm going to be posting the answers for homework 3 very soon after the due date. So I think the due date is Sunday midnight, and you're going to be using exactly these commands that we talked about today. So make sure you nail that one. And I'll be posting the solutions right after. So you will still need to wait until Sunday night, because that's the due date, if you want to see the solution. If you are comfortable with the material, you may want to start the midterm on Sunday. I don't know which one will suit you better. Okay? If you have any other questions, so we don't have a Zoom session next week, but I will record status cues, just as additional commands and things that you can do using Stata. This is not mandatory. It's only if you are interested in going deeper with Stata knowledge. They are not necessary for your project. I will not ask you that, but I will record that session, which was supposed to be week 6. So I'm going to go ahead and record that and post. So your only 2 things for next week is, besides finishing homework 3, is to just do the midterm, do well, please. I'll try to be gentle. If I'm not, if I somehow pitch it too hard, it's very hard for me sometimes to, problem of information asymmetry. So if somehow I pitch it hard or something, I will scale the midterm. So that's something I will do if necessary. So if you need to meet with me, send me an email. I'm available, but there's no Zoom session. Enjoy your holiday with your families. Take your midterm, and if you want, please watch the session that I'm going to record on Stata skills. Okay, we're going to be meeting after the holiday to talk about then panel data analysis, and that's going to be the very last important topic before we say goodbye. And I'm also going to see if I can bring Cook Medical to talk to you. Any questions before we say goodbye? Yes, so Dan is asking me insight on midterm format. So multiple choice questions 2 or 3 open questions. Again, we talk a lot about regression, selection bias. Of course, those things are very important. Hypothesis testing, I cannot emphasize that enough. And really this whole idea of mitigating endogeneity, I think that's very important. So 2-stage least squares are going to be there. Yes, so Scott is asking me, for 2-stage least squares, are we to use the IV regress? Yes, so the IV regress is the more updated version, Scott. You can still use IV reg, but you know, the common practice now in the industry is to use this written version, more recent written version, IV regress to SLS. Okay, all right. Open questions similar to quiz. Perhaps the quiz questions may be a little bit more specific. I'll try to, you know, really focus on the most important points that I think is important for you. Again, we have a lot of variance in this class, right? We have people that have not taken econometrics before, so I need to be mindful of everyone, and it's hard to say. I haven't written the open questions yet, but again, I want them to be focusing on the most important points, not the epsilons and deltas, little things. But really, instrumental variables is also going to be part of this exam. You're not going to need data anywhere in the exam or Excel, okay? You will only be, I don't want to mess up with software, so if you are traveling, if you are, you know, in a different environment, you are not dependent on that. All you need is your material, so make sure you know where everything is. So if it's a question on 2SLS, where do I look for? Or if I haven't time to study, that's a reality, right? You are a professional. Please, the more you are able to locate and be able to remember where things are, I think that's going to be more efficient for you. Multiple choice questions and open questions. Exam is time, 3-hour limit. Once you start, you have 3 hours to complete. So, okay. They are a combination of theory and interpretation. So I can show you a state output and ask you things about, you know, interpretation of that output. So this is something that is important, maybe on the exam. Yes, so Nate is asking me about the tables, and that's part of what I'm going to record next week. So how to make professional tables using Stata. This is done by installing a certain package in Stata. So you need to install a certain package called SOut, and I'm going to go through all the steps that you need to build those professional tables, to play with graphs a little bit. So it's going to talk about tables and graphs and other commands. You can do this manually, Manish. It doesn't need to be professional. You know, you can just take them to Excel and just do this table. I'm not going to require the Stata version. Okay. All right. So I'm here to help. If you have any questions moving forward, of course, as you are studying, if something is not clear, feel free to reach out. Instructions. So Damien is talking about some instructions. I'm not sure which instructions. About the midterm, you mean, Damien? For creating tables. Okay, perfect. That's good. Yes, definitely. You can look at those too. If you want to use them in your homework, that's fine. Okay, so let's end up here because I know you're off to the next class. Thank you for joining me as always, and have a good night with your friends and family. Thank you very much. See you guys, not next week, but on the other week. Thank you, and good luck on the midterm. Make me proud.